Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to design Combline bandpass filter. So this is the general configuration of Combline bandpass filter. The Combline bandpass filter is comprised of an array of coupled resonators. The resonators consist of line elements 1 to n, 0 to n plus 1. So the resonators consist of line elements 1 to n, so which are short circuited at one end, with a lumped capacitance C suffix Li between loaded between the other end of each resonator. The input and output of the filter are through coupled line elements 0 and n plus 1, which are not resonators. With the lumped capacitors present, the resonator lines will be less than lambda g by 4 long, where lambda g is the guided wavelength. So now here in this design, I am going to design a 5-pole Chebyshev 5-pole Combline bandpass filter. So assume that a 5-pole Chebyshev low-pass prototype filter with 0.1 decibel passband ripple has been chosen for the bandpass filter design. So now here the bandpass filter is designed to have a fractional bandwidth 0.1 at a midband frequency is 2 GHz. In this design, the microstrip filter is designed on a commercial substrate. Now here I am considering the type of the material is Rogers RT or Duride 6010 with its dielectric constant is 10.2 and thickness of the substrate is 1.27 mm. So this is the layout of a microstrip Combline bandpass filter. So now open HFSS software. First draw the substrate. So now here calculate the length and width of the substrate. So in this layout, this is 5-pole Combline bandpass filter. So adding all these values, consider the length and width of the substrate is 21.6 mm and 19.4 mm. So adding these all values, so this is 0.8 and the spacing 0.56, this spacing is 1.64, this spacing 1.26 and this is 1.1. So adding all these values approximately consider, and its value is 21.6 and this length is 13.6. So consider the length and width of the substrate is 21.6 mm and 19.4 mm. Select the box, draw the box anywhere in the plane. Give the rename of this box. This is substrate. So change the type of the material. Now here I am selecting Rogers RT Duride 6010 and its dielectric constant is 10.2. So now change the dimensions of the substrate, and X size is 21.6 mm and Y size is 19.44 mm and height of the substrate is 1.27 minus 1.27 and X position is half of the X size value before indicating negative sign minus 21.6 by 2 and Y position is half of the Y size value before indicating negative sign minus 19.44 by 2. Z position is 0 mm. So click OK button, select fit all. So this is the substrate. So below the substrate we can design ground plane. Select the rectangular sheet, draw the rectangular sheet anywhere in the plane. Give the rename of this rectangular sheet. This is the ground plane. So the length and width of the ground plane is same as that of the length and width of the substrate, and x size is 21.6 mm and y size is 19.44 mm, and x portion is minus 10.8, y portion is minus 9.72. The ground plane is below the substrate. Now the height of the substrate is 1.27 mm. Jet portion is here minus 1.27 mm. And rotate this structure. This is the ground plane. On the top of the ground plane is substrate. So on the top of the substrate we can design Combline band pass filter. Select the rectangular sheet. Draw the rectangular sheet anywhere in the plane. So first draw the middle rectangular sheet, and now here the x size is 21.6 mm. X size is 21.6 mm and y size is 19.4 mm. First draw the middle rectangular sheet. Select the rectangular sheet, draw the rectangular sheet anywhere in the plane, and now change the dimensions of this rectangular sheet, and x portion is 6.8. Okay, axis is the z axis. This rectangular sheet length is 13.3 mm, length is 13.3 mm and width is 0.8, and x size is 13.3 mm and y size is 0.8. And y portion is 0.2, 0.4, half of the y size value. So this is middle rectangular sheet. And after that draw this rectangular sheet and this rectangular sheet. So first draw this rectangular sheet. So this rectangular sheet length is 13.25 mm and width is 0.25, and the spacing between these two elements are 2.42 mm. Select the rectangular sheet. So draw the rectangular sheet anywhere in the plane. So change the dimensions of this rectangular sheet. Axis is the z axis. X size is minus 13.25 mm and y size and width is 0.8, minus 0.8, and x position is 6.8 and y position is minus 2.82 and z position is 0 mm. Click OK button. And now select this rectangular sheet, copy paste this rectangular sheet, select this rectangular 2, press Ctrl C, Ctrl V. So change the dimensions of the rectangular sheet, and X position is plus 6.8 and Y position is and this is the Y axis and plus 2.82. Next draw this rectangular sheet and this rectangular sheet. So this element and this element, and the spacing between these two is 1.64 and this length is 13.26 and width is 0.8. Select the rectangular sheet. So draw the rectangular sheet anywhere in the plane. Axis is the Z axis and X size is 13.6 mm and Y size is 0.8 mm. And X position is minus 6.8 and Y position is minus 5.26. And select this rectangular sheet, press Ctrl C, Ctrl V. Next draw this element and this element. Select the rectangular sheet, draw the rectangular sheet anywhere in the plane. Change the dimensions of this rectangular sheet. Now the x size is 13.6 and y size is 0.8 minus 0.8 and x position is 6.8 and y position is minus 7.42 mm, z position is 0 mm. Copy paste this rectangular sheet, change the dimensions, plus 7.42. Next, draw the 50 ohm transmission line. Select the rectangular sheet. So draw the rectangular sheet anywhere in the plane. And y size is 1.1 and x size is 4. select this 50 ohm transmission line, press Ctrl C, Ctrl V, and Y position is plus 7.42 and Y size is plus 1.1. Click OK button. Now select this rectangular sheet and this 50 ohm transmission line. Click Unite button. These two are unique. And similarly select another end of the 50 ohm transmission line and this element. Click Unite button. These two elements are unite. Next, draw the via whole grounds. So design the via whole grounds here and between the strips this portion. Short circuited and via whole ground. Select the cylinder. Draw the cylinder anywhere in the plane. Give the rename of this one, and this is via whole ground, and type of the material is copper. So change the dimensions of via whole ground. Minus 6.4, minus 7 mm, and Z portion is 0 and axis is the Z axis. So I am considering the radius of the dipole is, the radius of the cylinder is 0.2 and height of the substrate is 1.27. So minus 1.27 mm. So click OK button. Select the cylinder, draw the cylinder anywhere in the plane. So give the rename of this one. This is via whole ground 2 and type of the material is copper. And the radius is 0.2 mm and height is minus 1.27 mm. select the cylinder, draw the cylinder anywhere in the plane. Now assign perfect E boundary to the this all elements and ground plane. Select (50 ohm) transmission line both the ends, rectangular 1, rectangular 2, rectangular 3, rectangular 4 and ground plane. Right click on that position, go to assign boundary, select perfect E boundary. So this is perfect E boundary. Now draw the rectangular ports and rotate the structure, and this is y axis and this is z axis, and select the plane YZ plane. Select the rectangular sheet. So draw the rectangular sheet anywhere in the plane, and this is port 1. Change the dimensions of the port 1. So now here the width y size is 1.1 and the height of the substrate is 1.27. So z size is minus 1.27. Now select port 1, right click on port 1, go to assign excitation, select lumped port, draw the new line integration from lower port to the upper port, successfully defined, click finish button. So this is lumped port excitation of port 1. Similarly assign lumped port excitation of port 2. Select port 2, right click on port 2, go to assign excitation, select lumped port. So draw the new line integration from lower port to the upper port, successfully defined, click finish button. So now coming back to XY plane and rotate the structure. So this is the layout of Combline band pass filter. Now set the analysis setup, go to the simulation. So now here the operating frequency is 2 GHz and maximum number of passes are 12. Maximum delta S is 0.02. Select the sweep type is fast and starting frequency is 1 GHz, ending frequency 3 GHz. Points are 101. So click OK button. Next set the create open region radiation boundary. So go to the model, right click on the model, select create open region. Operating frequency is 2 GHz. Click OK button. So this is open region boundary. So now check the design validation. Check validate. Click validate button. So design is successfully validated. And now start the simulation. Click analyze all button.